Okay, so back to the review assignment here. So number 2 on the open constructed response or open response. We've seen this a few times with number 2. So it's Cavalieri's principle. Um, Basically, what we're saying is if the corresponding, um, so when the corresponding cross-sectional cross-section areas are equal. And what they mean by that is that you've got these blocks. So this is the first block. It's got a corresponding block that's equal in area to it. So when the corresponding cross-section areas are equal and the heights are equal, the overall height for all of it, um, then the volumes must be equal. Okay, so compare the volumes of these two stacks, well, equal volumes, and then we'll refer back to the above. Okay, that's your justification. So pretty simple on that one. Next, another pretty involved question. So what we have is in the infield, there's 7,500 people. And in the grandstand, there's 5,500 people. We want to know which one's more smaller population density. So what that means is fewer people per square foot. Okay. I'm not sure. I don't know if the drawing's to scale, but um, we're going to assume it's not. So what we've got to do is we've got to determine, I'm just going to go with this area in here. I'm not going to count the stage on either one of them. Okay, so what I'm going to do is first the area of a full circle, okay, full circle is pi r squared. Okay, we'll do that. We'll calculate that, and then of course at the end we will cut that in half. Okay, so what we have is 92 pi. You're going to want to just go ahead and type that in. 92 squared times pi. I'm getting 26,590. 0.44 and some other things. Now for the half, for the half circle, semicircle, okay, what we have is we're going to cut that in half. So we're going to take 26,590.44 divided by 2, and I end up with 13,295.22. That's going to be your square footage, okay? And then we're going to convert that to a density. Density, what we teach, or at least I teach it, is stuff over space. I know that's not any technical term, but seems pretty simple to me. So our density for the infield, okay, we'll call it I for infield. The density for the infield, what you're going to get is you're going to have the 7,500 people, and you're going to have square footage of 13,295.22, and that's square feet. When you convert that, we'll go for our calculator here. When you convert that, we're looking at, where'd it go? 0.5641 people per square foot. And we're just going to compare that to what's over here at the grandstand. Okay. Now the grandstand's got a little more involved with it. What it appears is we have a rectangle. Okay. And we have also, actually it's two rectangles. The second rectangle is going to be a little strange. So this is the standing room rectangle. And we're going to have a bleacher rectangle. Bleacher is going to take some Pythagorean theorem and things like that to get the length of it. but they're both rectangles. So the area is going to be simply length times width. Um, so the standing room is 140 by 40. Okay, so 5600. That's the square footage for the standing room, but the bleacher is going to be tricky. All right, so kind of take a side view here. They're giving us, so this is where the bleachers are right here. Okay, giving us a side view. Now you can see that's essentially what they're saying here, right? What we have is a height of 15 and a length of 36. So the first thing is we've got to really get how wide the bleachers are to determine that. So we're gonna complete a Pythagorean theorem problem. Let's call this c squared, right? So you can combine those. What was that? I know it turns out 39, 1521. There we go. And take the square root of 1521, square root of c squared, and you get 39. Okay. Now, what that does is, let's go back to the normal view. So if we were, given a top-down view, what we'd have is our bleacher width, all right? You're looking down on it, right? That's going to be 39 feet. Now, it is still, what did they give us? The bleachers are 100 feet across, okay? So the area of this is going to be also length times width. So it's going to be 100 times 39. Okay, 3,900 square feet. All right, now we're going to add the two together over here. So we got a total for the, what is this, the grandstand. Okay, so we're at the total for the grandstand. You're going to add 5,600 with 3,900, and we're looking at 9,500. That's the total square footage for the grandstand. All right, now that is over the course of, let's see, 5,500 people. So now we're at the density of the grandstand. So it's the people, 5,500 people, okay, over the area of 9,500 square feet, and it's pretty close. The density of this is 0.5789 people per square foot. What they wanted to know, where was the question here? Which one has the smaller population density? So that would be over here at the infield. So the answer is going to be infield as the smaller density, population density. And we're getting near our time limit. The other problems are going to take too long, so I'll stop there and make another video for the next one.